Fourier Transform. Of this course, the students can able to do apply Fourier Transform and continuous time signal. Fourier transform representation of the periodic signal has been extended to non-periodic signal by letting the fundamental period capital T tend to infinity, and this Fourier method of representing non-periodic signal as a function of frequency is called Fourier transform. And the definition of continuous time Fourier transform: the Fourier transform of continuous time signal is called continuous time Fourier transform. Let x of t be the continuous time signal and x of j omega equal to Fourier transform of x of t. And the Fourier transform of the continuous time signal x of t is defined by x of j omega equal to f of x of t, which can also be written as minus infinity to infinity x of t into e power minus j omega t into dt. Of Fourier transform: the Fourier transform x of t exists if it satisfies the following distress condition: x of t should be absolutely integrable, that is integral minus infinity to infinity x of t dt less than infinity, and x of t should have a finite number of maxima and minima within any finite interval, and x of t should have a finite number of discontinuities within any interval. Inverse Fourier transform: the inverse Fourier transform of x of j omega, it is defined as x of t equal to inverse Fourier transform of x of j omega, which can be given as 1 by 2 pi integral minus infinity to infinity x of j omega into e power j omega t into dt. The examples by using this Fourier transform: first one, find the Fourier transform of the impulse signal. Here the Fourier transform of x of t, we know that the formula is x of j omega equal to integral minus infinity to infinity x of t into e power minus j omega t into dt, and the Fourier transform of the impulse function, that is del of t, can be written as integral minus infinity to infinity del of t x of t del of t into e power minus j omega t into dt. We know that del of t equal to 1 for t equal to 0 and 0 for t not equal to 0. Therefore, the whole values became 1. Therefore, we are substituting t equal to 0. This value became 1. Therefore, which is equal to 1. Therefore, the Fourier transform of the impulse Fourier transform of the double-sided exponential signal. Here, the double-sided exponential signal is given by Fourier transform of e power minus a into modulus of t. We know that e power minus at is for t less than or greater than or equal to 0, and e power at, which is for t greater than less than or equal to 0. And we know the formula, that is integral minus infinity to infinity x of t into e power minus j omega t. We are substituting the values in this equation. Since we are having the limit from minus infinity to infinity, we are splitting it into two terms. Next, we are combining this exponential term, that is e power. While we are after combining this exponential term, we are integrating this, and after integrating this, we are substituting the limit, and after applying the limit, and after simplification, we are getting the value as 2a by a square plus omega square. Therefore, the Fourier transform of the double-sided exponential signal is 2a by a square plus omega square.